All right. Good afternoon again, everyone. So hopefully you are almost done with the problem set. The problem set is due later tonight, right before midnight. So hopefully patapos na kayo. Or kung tapos na, just wait. Pag sinipag ako mamayang gabi, I'll start grading problems 1.1 and 1.2 again. So kung ayaw niyong mastorbo in the middle of the night mamaya kasi ang working hours ko usually ay hanggang mga 2 or 3 a.m. So, pag sinipag ako, pag wala na akong mapanood sa Netflix, so start ko na siyang gradean. And off niyo yung notifications niyo kay Canvas if you don't want to be notified or disturbed. Pakibago na lang yung settings. But I'll try to grade it as soon as I can to give you immediate feedback. Meanwhile, exercise 1.3 will be graded by your lab instructors. Medyo mas maraming problems yung sa 1.3. So kind of give them more time to give you feedback on that. All right. And then, yun. Tapos, for today, we'll start module 6. So hopefully you got the chance to download this module. So this is a separate module in a sense kasi kailangan kong isulat yung i-rewrite ng konti yung module on the principle of mathematical induction. Kasi in the Math 101 work text that we are using, PMI is discussed more towards the end of the course wherein diniscuss muna yung set theory and then after that dinevelop yung numeration system, specifically the set of natural numbers axiomatically using Piano's construction or Piano's axioms. So dahil nandun pa yung definition kung paano nabuo yung set of natural numbers, dun pa lang diniscuss yung PMI because you will see later that the principle of mathematical induction is reliant on the properties of the set of natural numbers. However, I thought na this type of proof, the proof by mathematical induction, is actually a very powerful tool na kaya ko namang i-discuss without the axiomatic notion kahit wala pa yung theoretical foundation ng set of natural numbers. So for now, probably, I'll give you a rough idea or an intuitive idea kung bakit nag-work yung principle of mathematical induction. Tapos saka na lang natin siya i-formalize once we have stated Piano's axioms. Gusto ko siyang gawin, number one, kasi nga powerful siyang method of proof at maganda na ilump siya kasama ng ibang methods of proof that we have discussed since the past few weeks, where we talk about the direct proof, proof by contraposition, proof by contradiction, and proof of biconditional statements. We also had proof of existence ng mga nakaraang linggo. Right, so maganda na idagdag ko na itong proof by mathematical induction. Tapos para magamit din natin itong proof by mathematical induction pag magpo-prove na tayo set theory or set theory concepts. And then another thing is that yung timing kasi medyo problematic. Pag i-retain ko siya dun sa bandang dulo ng course, there's a big chance, alam niyo naman ako, mabagal ako mag-discuss, there's a big chance na baka madaliin natin yung discussion ng PMI towards the end or baka maging reading assignment na lang siya. And I don't want to do that because the PMI is also a persistent topic in the sense na gagamitin nyo siya sa mga other courses like Math 155, Math 111, and so on. Because the principle of mathematical induction is used to prove theorems involving the set of natural numbers. So most likely, gagamitin din nyo to sa Math 103. So kaya dito ko na siya ipapasok kahit wala pa yung theoretical foundation. Intuition muna yung gagamitin natin para intindihin kung bakit nag-work yung proof by mathematical induction. So if you have your copies of the module, I started here by hindi ko pala nilagay yung usual ko nilalagay sa mga templates ko ng module na objectives for this particular module. But the objective for this particular module is to illustrate the use of the principle of mathematical induction in proving theorems, so that at the end of the module, you guys will be able to use this principle in order to prove some mathematical statements. Okay, and in particular, the principle of mathematical induction is used to prove theorems that hold for the set of all natural numbers. Okay, or isang subset ng set of natural numbers starting from the smallest natural number for which the statement is claimed until we cover all natural numbers greater than or equal to that starting number. Okay? Kaya lang, let's just set some things in order here. Tandaan nyo ba guys kung paano ko define yung set of natural numbers when we started talking about the number sets? Ano yung set n natin? Nag-start ba siya sa 1 o nag-start siya kay 0? Tandaan nyo ba? Hindi nyo rin matandaan, no? Pero personally, I prefer the set of natural numbers to begin with 1. So, ang set ko ng natural number, tapos ito rin yung nasa isip ko whenever we talk about the natural numbers before, ang n ay 1, 2, 3, 4, 5, and so on. Yan yung ginagamit kong convention sa Math 155, saka sa Math 174 and other maths that I'm teaching. Pero in the word text, ang convention pala niya, ang set of natural numbers starts with the number 0. Okay. Kasama pala sa n yung number na 0. And I don't think this is a big deal. So we'll just adjust accordingly. So, but as far as our principle of mathematical induction is concerned, gamitin natin na yung set of natural numbers ay nag-start sa 0. Hindi naman siya maging malaking deal. Nagkaroon lang tayo ng additional isang element. Okay? So, pagpalagay natin, for the sake of our discussion, sa PMI, lagi tayo nag-start sa n sa 0. Okay? Gusto ko sanang baguhin, kaya lang pag binago ko to, kailangan kong baguhin lahat ng statement ng n dun sa buong word text. So, ayoko namang baguhin yung buong word text. So, sundin na lang natin yung convention niya na nag-start siya kay 0. Though, actually, it is not a big deal. So, kung before ginamit nyo ay ang n ay nag-start sa 1, that's fine. I'll just make the appropriate adjustments. But starting now, when we talk about PMI, ang assumption na natin ang natural numbers nag-start kay 0. Okay? Tapos, the principle of mathematical induction will work for statements about natural numbers. So here, we consider a statement P about n to be a statement about the natural number n having the property n. Tapos kung yung theorem natin ang sabi niya ay si property P ay nag-hold sa lahat ng natural numbers o kaya si property P ay nag-hold sa lahat ng natural numbers greater than or equal to a certain natural number, then we can use the principle of mathematical induction to prove it. Okay? Ano yung sabi ng principle of mathematical induction? We can divide the proof by mathematical induction into 3 steps. First is the basis step. Yung basis step, gusto natin munang ipakita that indeed the property P is possessed by the smallest natural number for which it was claimed. So kung yung statement natin ay about sa lahat ng natural numbers, then sa basis step, kailangan nating ipakita that P of 0 is true o totoo yung statement natin kay 0. Alright? Tapos kung ang statement natin naman ay true for all natural numbers n greater than or equal to k, si k ay isang specific natural number, then kailangan natin ipakita dun sa basis step na si property P ay satisfied nung natural number k na yon, yung starting natural number. Kaya siya basis. Dito magsisimula yung chain of arguments. Kaya ang tawag sa kanya induction. Kasi it appears that nagsisimula ako sa specific examples tapos doon ko ginagamit or yun yung ginagamit kong pang-argue na totoo siya sa lahat ng natural numbers. So kailangan una basis. Dito nagsisimula yung chain of arguments. So halimbawa, mapapakita natin na totoo siya kay, so yung natural numbers natin, di ba, nag-start kay 0, then 1, 2, 3, 4, 5, and so on. So yung sa basis step, papakita natin totoo siya kay 0. So na-prove na natin totoo siya kay 0. And then the next part is the introduction or the statement of the hypothesis of induction. Ang hypothesis of induction natin is that P of M is true. So this is the hypothesis of induction or HOI. Okay. Sa HOI, ipapagpalagay natin na totoo yung statement kay natural number m, where m is an arbitrary natural number satisfying yung requirement ng theorem. So kung yung theorem sabi niya, this is true for all natural numbers m, so si m dapat generic na natural number. So kung ang sabi ng theorem, this property is satisfied by all natural numbers greater than or equal to 6, then si m ay isang generic number greater than or equal to 6. Totoo siya kay m. Right? Tapos, gagamitin natin itong hypothesis of induction for the induction step. Yung induction step ay pag-prove nito. So, ito yung induction step. We want to show that if P of M is true, then P of M plus 1 is also true. So, gamit yung hypothesis of induction na si property P ay totoo kay M, gusto nating ipakita that property P is also satisfied by the natural number M plus 1. So, in short, induction step, kung totoo siya kay M, gusto natin i-prove na totoo siya kay M plus 1. At tapos sabi ng principle of mathematical induction, if we can do that in conjunction with the basis step, then we are sure that the property P is satisfied by all natural number n. So ibig sabihin, totoo na yung theorem. And let's see intuitively bakit siya nangyayari. So halimbawa, na-prove na natin yung basis step, totoo siya kay 0. Tapos na-prove na natin yung P of M implying P of M plus 1. By the way, guys, gumagalaw ba yung screen ko sa inyo? Nakikita niyo ba yung sinusulat ko? Ayan, nagwi-wiggle ako using the laser pointer. Okay, thank you. Kasi tumigil na siya sa laptop monitor ko. So, okay. But it's good to know that nakikita niyo siya. Kaya lang medyo uncomfortable para sa akin na hindi ko nakikita na gumagalaw yung nasa screen ko. But anyway, so kung napakita na natin yung induction step, ibig sabihin, kung totoo siya kay M, totoo na siya kay M plus 1. So, gamitin natin siya. Kung na-prove na natin siya, alam natin by the basis step, totoo siya kay 0. Then since this is true for 0, then it should be true for 0 plus 1, right? Or P of 0 plus 1 must be true. So that means the statement holds for the next natural number 1. Tapos, babalik na naman tayo dun sa induction step. P of M implies P of M plus 1. Totoo siya kay 1, so dapat si property P totoo rin para kay 1 plus 1, which is 2. Oh, totoo siya kay 2, so dapat totoo rin siya kay 2 plus 1. So dapat totoo siya kay 3. Totoo siya kay 3, so dapat totoo siya kay 4, and so on. And the process goes on forever. We are completing a chain of arguments, and thereby, kahit na hindi natin siya exhaustively napakita sa bawat natural number, we are sure na yung property P ay mag-hold sa lahat ng natural numbers. Kasi nga, gawa nung basis step at saka gawa nung induction step. So parang, in a sense, na isa-isa natin na totoo siya sa lahat ng natural numbers without doing an infinite number of proofs. Dalawa lamang yung kailangan natin gawin. I-prove yung basis step, i-prove yung induction step, or gawin yung basis step at gawin yung induction step with the aid of the hypothesis of induction. Okay? Does that process make sense? Na-convince ba kayo na valid proof itong principle of mathematical induction? Kahit na sinabi natin na ang math ay isang deductive process, gusto natin mag-reason mula sa general papunta sa specific, and it appears na sa PMI, nagsimula tayo sa specific, tapos na-prove natin na siya ay totoo. Kaya nga, induction yung tawag sa kanya, hindi induction. Pero technically, the induction step is actually a deductive reasoning. Totoo siya kay M implies totoo siya kay M plus 1. It's a deductive argument kasi si M ay generic na natural number. Naging parang inductive lang siya kasi ginamit natin siya para maisa-isa na totoo siya sa lahat ng natural numbers. Okay? So I hope you are convinced bakit valid itong proof by mathematical induction, and I hope you appreciate its utility. Nakikita nyo kung saan siya pwedeng gamitin. Pwede natin siyang gamitin para ma-prove yung mga statements involving natural numbers. And probably to illustrate this process, let's consider example number 1. Unless you guys have some questions. Wala pa namang questions. Teka, may notif daw si Teams. Okay. May nag-chat lang pala sa Teams. Pero yeah, let's go back. Let's look at example 1. Example 1 says we need to prove that for all natural numbers n, the summation of 0, 1, 2, 3 until n is equal to n times n plus 1 all over 2. So this is a formula that is famously attributed to Carl Friedrich Gauss, one of the greatest mathematicians of all time. And legend says, na-prove niya to nung nasa elementary pa lang siya. Alright? Pinrove niya yung formula or dinerive niya yung formula para sa summation ng first n natural numbers. Okay? And it appears that the summation is equal to n times n plus 1 all over 2. So illustrate natin to. So yung statement P about 0 or P about n ay pag sinum natin simula kay 0 hanggang kay n, ang sagot daw ay n times n plus 1 all over 2. At yung statement P about n. Now, specific cases, if we want to look at P about 0, the statement P about 0, sum siya starting kay 0 hanggang kay 0. So, isa lang yung term din sa summation. Ito ay equal kay 0 times 1 all over 2. Okay? If you want to get the specific statement about 1, this would be 0 equals 1 times 1 plus 1 all over 2. That's P about 0, P about 1. Statement P about 2 is, hindi pala 0 to, 0 plus 1. Wala yung plus 1. Okay. Yung statement P about 2, yung left-hand side ay summation starting from 0 until 2. Hanggang kay n kasi yung sinasum natin equal to kay n times n plus 1 all over 2. And so on. And if you verify these equations, pag sinimplify niyo yung nasa kaliwa at nasa kanan, you will immediately see that P sub 0, P of 0, P of 1, and P of 2 are all true. Right? Kung gusto niyo gawin yung, kung gusto niyo siyang i-prove exhaustively, kailangan dapat gawin niyo to sa lahat ng natural numbers. But of course, it is impossible to do that. So ang gagawin natin ay principle of mathematical induction. Okay? But I hope the specification of the theorem is clear for all natural numbers. Okay? So kasi kailangan ko siya mamaya dun sa inductive step, saka sa hypothesis of induction. Okay? And now, if that is clear, then let's start writing the proof. So let's write proof. And then I'll put in parentheses, we're doing the proof by the principle of mathematical induction. Okay? Now we start with the basis step. So dun sa proof, hindi kailangan na naka-bullets pa yung steps. Lalagay ko lang dito yung steps para lang makita nyo kung ano yung mga parts ng proof, but it is not necessary to write all the steps into bullet form. Pwede kayong mag-stick sa essay format. That's perfectly fine. And then I forgot here na yung statement ay kine-claim for all natural numbers n. So let's see. Basis step. Gusto kong ipakita na totoo yung statement para sa pinakamaliit na natural number na covered ng theorem. Now, the theorem says this is true, or the statement is true for all natural numbers n. So smallest natural number for which the statement is claimed, ICP equals IC0. So let's check if P of 0 is true. So in the basis step, we want to show that P of 0 is true. Okay? And this is easy because you can start with, syempre, pinuprove natin ay equation. So sabi ko sa inyo, lagi tayong mag-start pag-prove ng equation sa isang side lamang ng equation. Usually we start with the more complicated side. Okay? If you look at this, n times n plus 1 all over 2, mas mukhang komplikado siya kesa dun sa lalabas na left-hand side kapag kasi n ay 0, right? So what we'll do is I'll start with the right-hand side. So that is when n is 0. So pwede nyo lagay dito when n is equal to 0, then we'll have 0 times 0 plus 1 all over 2. And this is just equal to 0, which is essentially p of 0. Okay? So napakita na natin na obviously, yung statement P ay totoo kapag ka si n ay equal kay 0, thus completing the basis step. Okay? Medyo minsan tricky isulat si basis step kasi napaka-obvious niya. So katulad nito, nag-substitute lang ako, sinimplify ko siya ay 0, pero nakita na natin na yung specification yung left-hand side kapag ka si n ay equal kay 0 ay isang term lamang, which is 0. And evidently, this guy simplifies to 0. So there's nothing else to be done there. It's quite obvious that the statement is true when n is equal to 0. Okay? Now, after the basis step, we want to state the hypothesis of induction. So we will assume that the statement is true for some natural number m, for some generic natural number m, or sa isang natural number m na pasok dun sa theorem. Again, the theorem is being claimed for all natural numbers m or natural numbers n. So kunwari, sa hypothesis of induction, isipin natin kunwari totoo siya para sa isang natural number m. And what is the statement P about m? That is 0 plus 1 plus 2 plus until yung summation matatapos kay m ay equal kay m times m plus 1 all over 2. Okay? This equation 1 will be our hypothesis of induction, and this is what we will use in order to show that P of m plus 1 is true. And usually it is helpful if you will write what you want to prove alongside with the with the HOI para makita nyo ano yung dapat kong gawin kay HOI para mapakita na totoo yung P of m plus 1. So here we want to show that P of m plus 1 is true. That is, yung summation mula kay 0, 1, 2, hanggang kay m plus 1, dapat ay magpa-follow yung formula na given sa theorem. Yung sa theorem, n times m plus 1 all over 2, palitan nyo lamang lahat ng n ng m plus 1. So we will have m plus 1 times m plus 1 all over 2. Ito yung gusto nating ipakita, right? We want to show that P of m plus 1 is true, so replace all n's you see in the statement by m plus 1. Box ko lang siya ng konti para hindi nyo isipin na part ito ng proof. Ito yung gusto nating ipakita, right? And I always include it, kahit hanggang ngayon, mapa dun sa actual proof or sa isang scratch paper, lagi kong sinusulat kung ano yung gusto kong ipakita. Okay? Because this will guide me kung paano ko gagamitin yung HOI para mapalabas itong statement na to. Okay? So we usually want to use the HOI in order to prove this particular statement. So papasok na tayo dun sa induction step. Okay? Hold on guys, excuse me for 30 seconds. Okay, now, tingnan nyo yung statement, tingnan nyo yung HOI. So pwede ko itong gamitan dun sa proof kasi premise siya. Remember yung induction step, P of m must imply P of m plus 1. And then when proving conditional statements, ina-assume natin or ginagamit natin yung premise. So ang premise natin dito ay yung equation number 1. And then ang gusto nating mapalabas yung nandun sa loob ng box, yung nandun sa loob ng WTS box. So what can I do? Anong pwede kong gawin sa equation 1? Kasi pwede ko nang gamitin sa equation 1. Part siya ng premise. Ano yung pwede ko siyang gawin to bring us closer to what we wanted to show? Any volunteers? Okay, yeah, Neil?
Sir, baka ano pa sir, pwede pong magdagdag ng m+1 both sides.
Okay, perfect. Yeah, thank you, Neil. Yeah, yun yung gusto kong gawin. Mag-add ng m+1 to both sides. I can do that again because equation 1 is part of the premise. Kasama siya sa assumption ng induction step. Siya yung parang foundation ng, kaya siya HOI. Kunwari, totoo siya. Kung totoo siya, pwede ako magdagdag ng m+1 to both sides para maging mas malapit na yung itsura niya doon sa WTS natin, right? So kung magdadagdag ako ng m+1 to both sides, okay, ganito yung mangyayari, right? And then we want to get this equation, yung nasa loob ng WTS. Now, the left-hand side is already there. So what we want to get out of this guy is the right-hand side of the WTS. Kung ano man yung gusto nating ipakita, right? So gusto ko mapakita na itong right-hand side nito ay pwedeng masulat as m+1 times m+2 all over 2. And actually for that, a simple algebra fix will do. So gamitan lang natin yung algebra skills natin. Ito ay m times, ito ay m squared plus m all over 2. Kasi ito ay magiging 2m plus 2 all over 2. Then we can add the two fractions together. We're going to have m squared plus 3m plus 2. Kaya lang medyo malayo pa siya dun sa gusto kong ipakita. Now, any suggestion? How can I make it equal to what I wanted to show? Ano yung last step? Ano yung pwede kong gawin kay m squared plus 3m plus 2 para maging kamukhang-kamukha na siya nung nasa WTS? Or titigil na ba tayo dito tapos mag-give up na? Oh, yes, Prince. Nauna si Prince. Okay, sabi ni Prince, factor out yung m plus 1. Yeah, that's correct. We can factor m squared plus 3m plus 2 as a product of two binomials, namely m plus 1 and m plus 2 all over 2. And you can say this is equal to m plus 1 times m plus 1 plus 1 all over 2. So kung mapapansin nyo, ito si n plus 1 all over 2, which perfectly fits what was to be shown. All right? So ibig sabihin, pag totoo yung HOI, magfa-follow na totoo rin yung m plus 1. So napakita natin totoo siya kay 0. So dapat totoo siya kasi P of m implies P of m plus 1. Kung totoo siya kay 0, dapat totoo rin siya kay 1, totoo rin siya kay 2, totoo rin siya kay 3, totoo siya dun sa susunod na natural number, and so on. And eventually, that process will cover all natural numbers. So we can say, therefore, that the sum of natural numbers k going from 0 to n, ay equal kay n times n plus 1 all over n for all natural numbers n. Okay, by the principle of mathematical induction. Okay, does that make sense? Or do you guys have any questions? Okay, walang tanong? Okay, I'll take it as naintindihan nyo yung proof. So let's try another one. Let's try example 2. Tapos ito na pala halos yung end ng module because we need to skip example 3 kasi yung example 3 kailangan na ng notion ng power set. Nung nagklase lang ako sa kabilang section, kaya saka ko na-realize na hindi pa pala pwede yung example 3 kasi kailangan kong i-define yung power set. Tapos nasa set theory pa siya. So saka na lang natin siya balikan pag nasa set theory na tayo. So let's do example 2 for now. And then probably next meeting, let's talk about the some of the problems in the exercise sections. I compiled a lot of examples there or exercises there. We can answer some of them on our class on Friday. Okay. Now let's prove this that for all natural numbers n greater than or equal to 1, 2 to the n minus 1 is less than or equal to n factorial. Familiar ba kayo dun sa n factorial? Hindi to galit na n lamang, so hindi siya pasigaw na n, kaya exclamation point yung gamit. So it's a mathematical operation, a unitary operation. Nang ibig sabihin ng n factorial ay, ipag-multiply lang natin yung mga numbers starting from 1, 2, 3, hanggang makaabot tayo kay n. So in general, n factorial is the product of 1, 2, 3, 4, all the way up to n. So in particular, 1 factorial is 1 kasi product siya simula kay 1 hanggang kay 1. 2 factorial ay product mula kay 1 hanggang kay 2. So ang 2 factorial ay 2. Ang 3 factorial ay product mula kay 1, 2 hanggang kay 3. So that's going to be 6. 4 factorial is product from 1, 2, 3 until 4. So that's going to be 24. 5 factorial would be what? Ano ang 5 factorial? 120. And then 6 factorial is 720 and so on. So ganyan kino-compute yung factorial. And then by convention, ang 0 factorial ay equal kay 1. Okay, so yung 0 factorial equals 1, yan yung napag-agreehan na values ng mga mathematician ni i-assign kay 0 factorial to make some of the operations consistent. So you can watch some videos kung bakit naisipan ng mga mathematicians na i-assign the 0 factorial ay equal kay 1. May dahilan kung bakit nila ginawa yan. Pero we don't need to worry about 0 factorial because the statement is only claimed for all natural numbers greater than or equal to 1. So si 0 ay hindi covered ng Theorem 2 or ng example 2. Okay, so let's try to prove it. But I hope that the notion of the factorial is clear. So kung ngayon nyo lang siya nakita, hopefully hindi siya ganun ka-shocking or ka-hirap intindihin. Okay? But let me know if you have some difficulty with that. Okay? So let's see. Proof, again, I'll use mathematical induction here. Okay? And then the basis step now will be quite different from the basis step we had in example 1, because now we will prove that P of 1 is true. So in the basis step, we want to show that P of 1 is true. Kasi ang pinakamaliit na natural number covered by the theorem is 1. So yun yung kailangan kong ipakita, right? Or in other words, sa scratch paper, pwede nyo i-spell out ano yung gusto kong ipakita, P of 1. So i-substitute nyo lang yung 1 sa lahat ng n's na makikita nyo dun sa statement. So that means I can replace n's by 1. So we'll have 2 to the 1 minus 1 less than or equal to 1 factorial. And then we'll have 2 to the 0 less than or equal to 1 factorial. But 1 factorial is just 1. But 2 to the 0 is 1. So it seems that P of 1 is true. Okay? So gusto nating ipakita, totoo tong inequality na to. And doing a preliminary analysis, so technically PA to, okay, sinimplify ko bawat isa, nakarating ako sa identity na 1 is equal to 1. So you just need to find a nice way on how to formalize that as part of your proof. Okay? So posible mag-start ka muna sa isang side, usually to the more complicated side. So I'll begin with 2 to the 1 minus 1. Okay? Mag-start ako sa left side ng inequality and show through some steps that would be less than or equal to 1 factorial, right? So 2 to the 1 minus 1, tapos equal to kay 2 to the 0. 2 to the 0 ay equal kay 1. But we know that 1 is less than or equal kay 1. Ito yung nakuha nating identity mula dun sa preliminary analysis. But 1 can be written as 1 factorial. Okay? So indeed, we have shown that 2 to the 1 minus 1 is less than or equal to 1 factorial. Therefore, telling us na totoo yung basis step or totoo yung statement for the smallest natural number for which it was claimed. Okay? Now that's the basis step. Next, we need to state the hypothesis of induction. we will assume that the statement is true for some natural number m greater than or equal to 1. Kasi nga, ang usapan, yung theorem dapat totoo sa lahat ng natural number n greater than or equal to 1. So yung HOI natin, i-assume natin totoo siya sa isang generic natural number which is greater than or equal to 1. Okay? Ito yung statement na yon. So kung totoo siya kay m, so dapat ang 2 to the m minus 1 ay less than or equal kay m factorial. Okay, so this is something that we will hold on. We will assume this is true in order to show that P of m plus 1 is true. So ibig sabihin, balikan na naman dun sa statement, lahat ng lahat ng n, palitan natin ng m plus 1. Okay? So mula dito, palitan ko lahat ng n, ng m plus 1 para makuha ko kung ano yung goal natin, ano yung WTS. Okay? Can anyone volunteer? Ano yung WTS for this particular statement? What do you want to show? Anong inequality? Iba naman. Sorry, Prince. Try natin kung may iba pa mag-volunteer. But I appreciate your participation. Sige, unahin ko muna si Trisha. Hi, Trisha. What do you think is the thing that we want to show?
2 raised to m plus 1 minus 1 less than or equal to m plus 1 factorial.
Okay, great. Thank you, Trisha. That's right. We want to show that 2 to the m plus 1 minus 1 is less than or equal to quantity m plus 1 factorial. And what Trisha did there is just replaced lahat ng n's dito sa nasa theorem, inequality ng theorem, pinalitan niya lang lahat ng n by m plus 1. Then we can further simplify this and say, okay, gusto lang natin ipakita ng 2 to the m ay less than or equal kay m plus 1 factorial. Okay? Box lang natin to. Tapos ilalagay ko siya on the side para siya yung magiging guide para dun sa gagawin nating proof. Okay? Now, again, to prove that P of m plus 1, most likely, I will begin with the hypothesis of induction, or the hypothesis of induction will form a very central role in the proof that P of m plus 1 is true. So, alam na natin yung assumption o yung premise. Alam ko na yung gusto nating kapuntahan. So, any suggestion, how can I bring the premise closer to our goal? Ano kaya yung pwede kong gawin? Clue, gagawin ko siya dun sa inequality na to. Ano yung pwede kong gawin sa kanya? Something that we know to be valid or something that we know is true. Mula sa mga usual properties ng inequalities na alam na natin. Okay, volunteers? Kahit tula. So, hindi naman kailangan tama para makakuha kayo ng recitation points. Kahit mali yung sagot nyo or half correct, basta gusto ko lang yung participation nyo makita. Okay, Neil Christian. Nakasagot ka na nga ba, Neil? Parang nakasagot ka na kanina. Or hindi pa?
Tapos na po pala.
Okay. Kaya lang parang wala na akong choice. Si Prince, si Trisha. Sige, pilitin ko yung iba. Jasmine. Meron kang hula? Ano kaya yung pwede kong gawin? Paano ko mapapalapit itong assumption papunta dun sa WTS?
Sir, ang naisip ko po, sir, is mag-add po ng 1 on both sides para makuha po sana yung nasa loob po ng parenthesis na m plus 1.
Okay. Yeah, thank you, Jasmine. Pero may problema ron kasi kung mag-add ako ng 1 to both sides, ganito yung mangyayari. So, magkakaroon ako ng m plus 1 dito. Tapos mag-add ako rito ng 1. Ang problema, walang property ang factorial that will allow us to put the 1 here inside the factorial. So yung plus 1 dito, ma-add siya after we take the factorial. So kaya medyo may problema ron. Pero I think I know what you're trying to do. You want to have m factorial become m plus 1 factorial. Pero iba yung kailangan nating gawin para mapakita na si m, para makuha si m plus 1 factorial coming from m factorial. But good try though. Alam ko yung gusto mong gawin, kaya lang medyo sabi tayo dun sa properties of factorial. But thank you, Jasmine. Sige, try ko naman si Perlene. Hi, Perlene.
Hello po,
ano
sir. Ayun
Hi.
din po kasi naisip ko. Sorry
Okay.
po.
No problem.
Isip pa po ako.
Yeah. Okay, no problem. So, huwag kayong mag-sorry kapag ka sa mga tries. So, ganun talaga sa math. Para yung pag-aaral ng bicycle. Hindi ka matututo pag hindi ka sumemplang. Ano? So, i-treasure natin yung mga struggles na yan o yung mga klase ng mistakes, and hopefully we'll learn from it. Okay? Sige, next, si JR. Hi, JR. Tama nga ba JR ang nickname mo, John Rafael?
Opo, sir.
May idea ka ba? Ano yung pwede kong gawing susunod? Actually, there are two possibilities. Pero may suggestion ka ba aside from what Jasmine and Perlene suggested?
Sa tingin ko po, na always greater naman yung 2 raised to 1 sa m factorial, m plus 1 factorial or 2 plus 1 factorial. Wait. Kaya siguro pwede yung 2 raised to m minus 1 plus 1 less than or equal to m plus 1 factorial.
But essentially, yeah, tama ka. Totoo siya palagi. Pero yun yung gusto kong ipakita. So, dito ako mag-start. Ano kaya yung pwede kong gawin muna dito? Bago makapunta dun sa dinidescribe mo, JR. Sige, try natin yung mga nagtaas ng kamay. Sige, yes, Prince. Ano yung gusto mong isuggest na pwedeng gawin? Okay, tingnan natin. Magta-type yan si Prince. Habang nagta-type si Prince, sige, Trisha, ano yung naiisip mo na paraan? Oops, camera pala yung na-open ko. Okay, Trisha, may suggestion ka ba?
Nag-iisip pa po.
Okay. How about Neil? Nakita ko nagtaas ng kamay si Neil.
Sir, ang naisip ko po, sir, sir, baka pwedeng i-multiply po siya sa m plus 1 since, yung m plus 1 yung both sides. Sir, kasi para maging m plus 1 factorial yung kabila or i-multiply sa 2 para maging 2 raised to m yung kabila.
Okay, sige, try natin parehas. Thank you, Neil. Yung una mong suggestion, multiply both sides by m plus 1. And then yung suggestion ni Prince naman dun sa chat ay multiply both sides by 2. Both of them will work. Piliin ko kung ano yung gagawin ko muna. Alright. So, gawin natin yung suggestion muna ni Prince. Multiply daw ng 2 to both sides. Bakit siya nag-multiply ng 2 to both sides? Kasi nakita niya, yung left side dito ay 2 to the m minus 1. And then the left side here ay 2 to the m. So, kulang ng isang factor na 2 yung nandun sa HOI para makuha yung nasa WTS. So here we can multiply both sides by 2. Okay. So yun yung suggestion ni Prince. The reason why he suggested that ay para yung right-hand side maging 2 to the m less than or equal to m factorial times 2. Alright? On the other hand, yung suggestion naman ni Neil ay mag-multiply both sides ng m plus 1. And siguro ito rin yung tinatry ni Jasmine kanina. So m factorial times m plus 1. But you need to be careful. Balikan natin kasi ang gusto ni Jasmine ay makakuha ng m plus 1 factorial. So ano nga bang ibig sabihin ng m factorial? Ang m factorial ay 1 times 2 times 3 hanggang m. Pero yung gusto nating marating ay m plus 1 factorial. yung m plus 1 factorial ay 1 times 2 times 3 hanggang m times m plus 1. So kung mapapansin nyo, parehas sila ng first m factors. So ang kulang lamang kay m factorial para maging m plus 1 factorial ay yung additional factor na m plus 1. And I think that's why Neil suggested na mag-multiply ng m plus 1 to both sides. So pag ginawa natin yon, masisimplify ko naman yung, drawing ko na lang yung line ulit. Masisimplify ko yung right-hand side, pero yung left-hand side medyo problematic ng konti. But we'll go there later, okay? So m plus 1 factorial. But I hope it's clear now how we got the m plus 1 factorial out of m factorial times m plus 1, okay? Para ngayon, magkaiba si Neil at saka si Prince ng approach. Yung una, si Prince, gusto niyang yung left-hand side maging kamukha nung given dun sa WTS. Si Neil, gusto niya naman yung right-hand side, yung unahin niyang maging kamukha nung right-hand side yung nasa WTS. So let's probably start with Prince's suggestion. Feeling ko mas madali ito. Because you will get two individual or two separate proofs or two independent proofs mula dun sa suggestion ni Prince sa saka ni Neil. Bahala kayong pumili kung ano man yung una yung naisip na ilagay dun sa submission niya. Pero isa lang sa kanila is enough to show that indeed the statement is true. Okay? So let me try this one. Okay. 2 to the m, alam na natin, ay less than or equal kay m factorial times 2. Gusto ko ito ay maging m plus 1 factorial. Tapos ang alam lang natin ay para makakuha ng m plus 1 factorial, dapat ito ay papalitan ko ng m plus 1. Okay? So, however, but you can say na meron pa akong isang trick out of my sleeve. But it is clear to see that for any m greater than or equal kay 1, okay? Kasi ito yung assumption sa theorem, si m ay greater than or equal kay 1, then it will follow that m plus 1 is greater than or equal kay 2. Okay? Or in other words, or equivalently, ang 2 ay less than or equal kay m plus 1. Okay? So, ibig sabihin, si m plus 1 ay laging mas malaki kaysa kay 2. So, ibig sabihin, kung itong expression na to, m factorial times m, yung 2, pwede kong palitan ng m plus 1. And m plus 1 is a number that is greater than or equal to 2. So, kung dito sa m factorial times 2, yung second factor ay papalitan ko ng something na mas malaki sa kanya, or possibly mas malaki sa kanya, the number that I will get will be something that is larger. So that means m factorial times 2 will be less than or equal kay m factorial times m plus 1. Or pwede niyong tingnan na lamang as from here, I multiplied both sides by m factorial, right? And m factorial is a positive number, so the inequality won't change. So in effect, what we have seen here is that m factorial times 2 is less than or equal to m factorial times m plus 1, which we know is equal to m plus 1 factorial. So ibig sabihin, si m factorial times 2 pala ay laging mas maliit or equal kay m plus 1 factorial. Pero si m factorial times 2 ay mas malaki or equal kay 2 to the m. So by transitivity, okay, so 2 to the m is smaller than m factorial times 2, or is less than or equal to m factorial times 2, but m factorial times 2 is less than or equal to m plus 1 factorial, so therefore 2 to the m must be less than or equal to m plus 1 factorial, which is what we wanted to show. So here you can conclude your statement. So therefore, ang 2 to the n minus 1 ay less than or equal kay n factorial for all n greater than or equal to 1. For all natural number n and n greater than or equal to 1, and the proof by the principle of mathematical induction. Okay? So this is one proof that you can write. So questions muna bago tayo pumunta dun sa proof na suggested ni Neil. Yes, Jasmine.
Sir, medyo nalito lang po ako dun sa may, yung minultiply po sir sa 2 and then ang naging answer po is 2 raised to m. Tama ba? 2 raised to m. Parang hindi ko po masyado na-gets paano po siya naging 2 raised to m po. Kasi parang naisip ko po is 4 po siya. Tama po ba? Kasi,
Okay, yeah.
ayun.
Be careful lang, Jasmine. Yung 2 rito, pwede mo siyang isipin na 2 to the first power. Okay? So kapag remember laws of exponents, pag nag-multiply ka ng dalawang expressions na parehas yung base, ang gagawin lang natin, i-add lang natin yung exponents, right? So 2 to the 1 times 2 to the m minus 1. So magiging 2 raised to the 1 plus m plus 1. 1 plus m minus 1, which will result to 2 to the m. Parang ano lang yan, x squared times x to the third power, ang sagot ay x to the fifth. Nag-multiply tayo ng, nag-add lang tayo ng exponents pag nag-multiply pag parehas yung base. Yun nga lang dito, specific number yung x, ginawa natin 2. So yung 2 to the 1 times 2 to the m minus 1 is copy the same base and then add the exponents. 1 plus m minus 1, we're gonna get m. Okay?
Thank you po.
All right, no problem. Tanong ni JR, ano yung process of transitivity? Yung process of transitivity ay kapag ka si A ay less than or equal kay B, tapos si B ay less than or equal kay C, magfa-follow na si A ay less than or equal kay C. Okay. Wala tayong formal proof dito, pero sa Math 155, pinrove namin ito. Pero for Math 101, let's accept this to be a basic fact. So kapag ka si A ay mas maliit kay B, tapos si B mas maliit kay C, so necessary na si A mas maliit kay C. So yun lang yung transitivity, yan yung transitive property. Okay? All right, you're welcome, JR. Okay? And then, utang siguro ako ng konti pang minuto para ipakita ano naman yung brand ng proof o ano naman yung proof na makikita nyo kung gagamitin natin yung suggestion ni Neil. So, wala tayong problema na rito kasi m plus 1 factorial na siya. So, dito, kailangan ko naman ay, ito yung problema ko. Dapat mapalitan ko ito ng 2 para makabalik dun sa 2 to the m minus 1 times 2, which will become 2 to the m. So, I need to change this into 2. But I can note that, again, ang assumption natin kay m ay si m ay greater than or equal kay 1. So that implies that m plus 1 is greater than or equal to 2, or that's equivalent to saying that 2 is less than or equal kay m plus 1. So ang gagawin ko naman, punta ako sa left-hand side, papalitan ko si papalitan ko si m plus 1 by something smaller. So if I will replace this factor by something smaller, yung makukuha ko na number ay mas maliit, right? So again, si m plus 1, papalitan ko by a number that is smaller than it, which is 2, right? So magkakaroon ng 2 to the m minus 1 times 2. Dahil yung second factor, pinalitan ko by something that is possibly less than or equal to it. So yung resulting inequality would be less than. Yung resulting expression ay mas maliit possibly dun sa original expression. Or you can simply think of here as I multiplied both sides by 2 to the power m minus 1. Okay? Pag minultiply ko to ng 2 to the power m minus 1, I will get to the left side of the inequality a 2 to the m minus 1 times 2, which is the same as 2 to the m. And then the right-hand side would be 2 to the m minus 1 times m plus 1, which is exactly what we have in the left-hand side here. So by transitivity again, so it will follow that since 2 to the m is less than or equal to this guy, but this same guy is less than or equal to m plus 1 factorial, so therefore 2 to the m must be less than or equal to m plus 1 factorial, which is what we wanted to show. All right? And this will also end your proof. pupunta ka na dun sa conclusion natin katulad kanina, and you'll get a slightly different proof than what we have gotten using Prince's suggestion. Okay? So, pili lang kayo kung ano man yung naisip nyo. It's perfectly valid. Either you do this, you get perfect score. If you do this, you get another perfect score. Okay? Bahala na kayo kung ano sa tingin nyo yung mas madaling gawin. Okay? All right. So, does that proof or do those two proofs make sense? Okay lang ba? Yung dalawang proofs na yun. Pili lang kayo ng isa kung ano yung una yung naisip. Okay? Now, the principle of mathematical induction is a very powerful tool. Kaya gusto ko siyang ituro ngayon pa lang para pwede na natin siyang gamitin pag magpo-prove tayo ng properties ng sets. Katulad dito sa example 3, sinasabi niya yung power set ng isang set na may n na elements ay 2 to the n yung laman. So, I don't know if you guys are familiar with Mathmatch during the weekend. Isang tanong nila yung pagko-compute ng power set. And parang walang nakasagot noon, no? Kung nanood kayo ng Mathmatch nung weekend. Parang walang nakasagot na yun noon. And I'm a little bit surprised kasi known formula to para sa problems, para sa power set. But we'll revisit example 3 when we define the power set of a given set. Okay? Kung makalimutan ko siyang i-prove kasi wala siya obviously dun sa examples sa work text kasi nasa dulo pa nga yung PMI. So paalalahanan nyo na lang ako na, sir, may utang kayo na proof. Yung proof ng power set, ng cardinality ng power set ay 2 to the n. Okay? Prove natin siya kapag na-define na natin ano ba yung power set. Okay. So, yeah. Tingin ko nga, JR, baka hindi pa siya na-define nung, kasi ang Mathmatch ay high school students, no? Baka hindi pa na-define sa kanila yung power set ng isang set. Or nalito sila pagbibilang ng elements ng set A kasi may mga subsets na nandun. So, yeah. So senior high and junior high. So baka nga. So, kaya nung umpisa medyo bothered ako. Bakit hindi nila nasagot yun? Specific property siya ng sets. Tapos ako naalala, hindi nga pala to Math 101 students. So, senior high and junior high pa lang sila. So baka hindi pa naituro. Pero after nating i-discuss yon, so dapat JR masagot mo na yung problem na yun sa Mathmatch. Okay? So, yeah. Lagay ko kaya yun as part of one of your quizzes or homeworks, no? But anyway, that's it. So on Friday, we'll try to solve some of the problems in the exercises because the module only provided 2 worked examples. So we'll spend our discussion on Friday looking at some of the problems here. Dito rin yata ako kumuha ng pampa-worksheet. So kasi ako yung sumulat ng worksheet 6 at saka nitong PMI exercises. So let's try to answer some of these. Ito lang pala guys, I might not be around on Friday, unfortunately. Baka nasa biyahe ako ng Friday. So I might not be able to join you live, but I will just share to you the recording of our class nung section T, which will be tomorrow. So if you wanna join the class live, pwede kayong umattend bukas ng Math 101 section T. Yung link ay nasa Canvas webpage natin. Tapos ang time slot na ay 9 to 10 tomorrow. So if you are free and you want to join live, then you can join us there. Tapos kung naghahabol din kayo ng recitation points, pwedeng doon kayo mag-recite. It's perfectly fine. Wala akong distinction kung section T or section H kayo. But if you don't have time to join us tomorrow morning, kung masyado siyang maaga for you or merong conflict, so you can just watch the recording at your own time. So right after naman ng klase, siguro a few minutes after, I can provide the recording in Canvas. Makikita niyo na siya dun sa recording page. Or pwede niyo puntahan yung YouTube playlist ko ng Math 101 Section T. Pwede niyo siya dong hanapin. Pwede ko rin pala siyang pangalanan na yung recording ay Math 101 HNT para join na rin kayo doon. Okay? So I hope that's fine. But I'll be back to join you live on Wednesday next week. And then I think that's it. Yeah, saktong 6:30. All right. So again, reminder, deadline ng problem set later tonight, and I'll try to start grading kasi tumatambak na 88 na yung problems na kailangan ko tsakan. Hopefully matapos ko siya bago mag-reading break para immediate yung feedback sa inyo. And yeah, and then again, watch the recording na lang for Friday's session. And then let's see each other again on Wednesday. Enjoy your, actually, hindi pala Wednesday next week, no? Reading break na next week. So enjoy the reading break, guys. Take some time to re-energize para ready na kayo para sa susunod na kalahati ng semestre. Okay, guys. Thank you. Have a good night and take care. Stay safe,
Sir,
guys.
sir,
Bye.
wala sa team po, sir.
Okay. Dapat pala may deduction ka na, Neil. Hindi ka pa nag-member ng Teams. Ayan, lahat na nag-recite nga pala verbally, paki-comment naman. Actually, lahat pala kayo ay nag-recite ngayon. So yung mga members ng team, pa-comment naman sa meeting chat nung nicknames nyo. Si Jasmine din, di pa member, no? Tama ba, Jasmine? How about you, Perlite?
Okay na po ako, sir. Nakaka-access na po sa lahat. Pati po emoji and chats po.
Okay, great. Thank you, Perlene. Yeah, pa-comment na lang ng pangalan mo, Perlene, o ng nickname mo dun sa chat para ma-record ko yung recitation niya for today. Okay? Also, JR. Nagsagot din si
Kaso
JR.
po, sir, hindi po ko... Hindi... kasama po yun, sir. Included po.
Alin yun, Perlene?
Hindi po kasi ako, sir, nakasagot since yung naisip ko po ay yun, same lang din. Kung included po ba
That's
yun.
fine. Counted na rin yun.
Okay, thank you, sir.
Alright. So, participation naman yung kailangan ko. Hindi correct answer. Gusto ko yung participation. So, kindly just comment your name there. Okay, so bye, guys.